Hello. Welcome to the power of strongly coupled GraphQL queries for internal APIs. It's very catchy. It's really hard to have technical talk presentations that are descriptive but also fun. Okay, so we'll go through an introduction, what this talk is all about. I'll give you some context so that you'll be able to understand the examples. And then we'll talk about kind of how our team used to use GraphQL and how we've switched to using it, and then some alternatives that we'll cover briefly and the conclusions. My name is Mary. I live in Victoria, BC, which is in Canada, if anybody doesn't know. I'm the tech lead at a small company called Tutored by Teachers, and I used to work at Shopify, which was a big GraphQL shop, and I graduated from the University of Waterloo, which maybe somebody here did. There are a lot of people here from Waterloo. Okay, so this talk is about highly coupled GraphQL queries, and what that means is for internal APIs specifically, it's advocating for the idea that we should ask for only the data that we want. So we don't want to have to do additional filtering on the front when it's possible to avoid it. And then we also want that data in the shape that we want it. So we also want to avoid additional data mapping if we can help it. And then one of the big themes of the talk is getting over that fear of duplication when the trade-offs make it worth it. So if you follow this technique where you're asking for exactly the data that you want in the shape that you want it, there are going to be situations where on another page you want that same data but in a slightly different shape, and it's going to be really tempting to slightly modify that query so that it'll fit both cases. But this is an advocacy for not doing that and being okay with some duplication. So to go through this example, we're going to have a team of helpers, and they, like me, work at Tutored by Teachers. We have Sally, the software engineer, Billy, the product manager, and Lily, who's the big boss. And they work at Tutored by Teachers, which is a company that basically connects students with certified teachers, and they do that by going to the school district to sign these students up for tutoring. So parents don't sign up their kids for tutoring. You go to the school district says these kids need some tutors, and they set that up. And so we'll just go briefly over the data models that you would imagine Tutored by Teachers would have. You probably can't see here, but we've got students, we've got teachers, and then we have something called a cohort, which is a group of students who are being taught by a single teacher. And as you can imagine, cohorts meet every so often. So when they meet, it's a session, and sessions happen at a particular date and time. And then for a session, we might want to record like how many students actually showed up. So we also have student session attendance records for those sessions. So yeah, that's just a bit of background. And so what I'll go through now is I'll go through an example that happened at Tutored by Teachers, basically, where small intuitive decisions kind of cascaded into a bit of a mess in terms of our schema. And then we'll talk about the new approach that we've been using that has required some of this rule breaking. I couldn't connect to the internet, so this is a bit blurry, but that's fine. So this is kind of the start of, let's say, the first page that Sally had to write for Tutored by Teachers. And it's just a list of the cohorts that we mentioned, the groups of students and the teachers. And so to create this page, it made a lot of sense to write something like this. Okay, we can fetch cohorts, and so we have a very specific cohort type, and under that you can get the specific teachers for that cohort, the events, the student count, basically all the stuff that was needed for this page. And then another one that similar intuitively, you kind of say, okay, for every cohort, we have this list of sessions. We have a table with a list of sessions. So, okay, well, that makes sense. We already have the cohort type. Let's nest sessions underneath that. We can fetch that. And it fits really nicely into that table that we saw. So these are already types that we have. And so when Billy comes up to Sally and says, hey, we actually need a new dashboard that shows this week's attendance percentage for every cohort in the school district. So it's a bit of a more complex dashboard. But Sally thinks, well, okay, what do I need to do to actually show this dashboard? I need to get the cohorts for a specific school district, and then I need the sessions for each date of this week, and then the attendance records for each session, and then I can calculate the percentage of present students. And that's great, because we already have a lot of those GraphQL types. We have the cohorts, we have the sessions, it's all nested nicely. So, this actually doesn't require actually any backend code, and we can fetch these cohorts, the sessions, and then the student attendance records. But then comes the data mapping on the front end. So now, because we're fetching all the sessions, we have to filter out the ones that aren't in this week. So we set the start date and the end date, and we filter out sessions that aren't in the current week. Okay, not so bad. Then we want to get the attendance records for each session. So we might have multiple sessions per weekday per cohort, so we need to do this accumulator where we check what date each session falls on, and if they both fall on the same session, we add them to the same array, and then we get this data in a format that's more easy to do this next step, which is calculate the average attendance for each weekday. And to do that, we get the full count of how many attendance records we have, and then we get a count of how many are present, and we do that calculation, and there is possibly a divide by zero bug here that I saw after I wrote this code, and I didn't want to rewrite it. But yeah, there are a few things that Sally already doesn't like about this. One is we're fetching all-time session data instead of only this week's session, so we're getting more data. And this could be fixed by adding a nested filter to the sessions query. That's okay. Next is we're setting the week bounds in the client. This is a small one, but now we might need to consider time zones because client could be in any time zone, and I just hate time zones. And then lastly, and this is the one I agree with most with Sally, is we're doing quite a bit of data mapping on the front end, but we're also potentially doing some data mapping on the back end. So if you look at this, the date might not be in the format that GraphQL needs it to be, or the status might not be in that format. And so that means that already when we're building the resolver in the back end, we're doing some mapping. And then on top of that, once we fetch it in the front end, we're also doing some mapping. And so if, God forbid, there's a bug, we have two places to look now to see where that bug might be coming from. But whatever, we did it. It's fine, it's working. Okay, but Billy lets us know there are just a few changes that we need to make. We want to ignore attendance data for students that have an excused absence for the day. So if a student isn't showing up for a day and they have an excused absence, then this record gets created where it has the student ID, the reason, and the date. And now you can see that on Wednesday, for example, we have a very low presence score, but that's because some of the students had an excused absence, so we want to ignore those attendance records from our calculation. Okay, so now under student attendance, we're fetching the student object as well, because we already have that in there, it's fine. And we're getting the excused absences, like the whole list of them, with a date as well. And then we have to add that into our mapping function where we say, okay, ignore students that have an excused absence for the day. It's not so bad. It makes it a little bit worse, but it's okay. Done. Okay, but the changes keep coming. It seems like this is a dashboard that we're actually going to be iterating over quite a bit. And so now what we want to do is we want to ignore attendance records for students that have been removed from the program entirely. So if there are no longer active students on any of the cohorts, we want to ignore their attendance records. But they still have attendance records because that doesn't go away. We also want to show a special palm tree icon for US holiday days. We have this holiday record or model, and there's a type, and if the type is US, we want to ignore those as well. Okay, so that looks something like this. They're not insanely complicated changes. They're fine. You know, we can add that palm tree there. We need to look at all the cohorts and see if the students are in any of the live or the current students. It's no problem. But then our GraphQL query is starting to look kind of unmanageable. You know, this is, now for every cohort, we're fetching the full list of students. We're getting all that data into the client. And then you can see also we're getting the students twice because we're getting a student under student attendance because we need the excused absences. And yeah, we can just remove that and get the excused absences from the students that we're fetching up top. But now this change that has nothing to do with that previously introduced change will require a new developer to know about it, to go in and to change that previous code to fit this new schema format that they're fetching. So it's just starting to be a little bit complex. And then also for holidays, you know, we're fetching a completely separate type. We're going to have to filter based off the type, and we're going to have to check the dates from the sessions. It's a lot considering this is an internal API. You know, we can just ask for the data that we want. And worst of all is Sally has to tell Big Boss Lily that things are going to take a little bit more time. And Big Boss Lily is not happy about that. So she's starting to think that maybe using our existing GraphQL types isn't the best option for a table that has so much aggregated data. Okay, well, what's the alternative? Let me check where I am for time. Good. The alternative is we ask for the data in the exact shape that we want it. And this already includes all of the previous changes that Billy introduced. And actually from the initial dashboard to what it would be after the changes, all that changed here was the is holiday addition. Because otherwise, it's just data filtering and different conditions for whether we're including the attendance records in the attendance average on the back end. The front end does not need to know about it. So as a reminder, this is what Billy asked of us. And you can see here that we have rows and we have columns. And the rows are our cohorts and the columns are our weekdays. And you can see that the shape that we're asking for is a bit rows and columns. We have our cohorts, and within the cohorts, we have an array of weekdays that we're also fetching. And if you've ever used React Table, you know that this fits really nicely into that. You can pass in your cohorts into the data, and then what will happen is a single cohort will then get passed through to each of the columns, and you'll be able to display that data without any data mapping, essentially, which is awesome. So your front end is super simplified. And then if we look at our back end, we use Prisma for our ORM, but you might have something completely different. You can see that our queries can get a lot more optimized. So we are passing in the start and end date right here to filter out sessions and excused absences that aren't relevant. And we're also doing include, so our SQL joins are going to be a lot more efficient. And what's really nice also is you can see here that we've added a status, not archived. And that's something that we can change only here, and it'll only impact that page. So if we have a different dashboard where we actually want archived cohorts to be included, we can not have that in there, or remove it and add it, and it won't impact anything else. It's all just for this dashboard. Yeah, so The benefits are it's faster, less data is queried from the database, more optimized queries, less data is actually sent to the client, so it's just, yeah, faster. My personal favorite is the separation of concerns. The front-end code becomes responsible for UI only, so no business logic. The back-end is responsible for all the business logic. And it's easier for other people to change this code with confidence. You know, you kind of know that when you're changing this code here, it's not going to cascade anywhere else. There's potentially some security benefits where you don't have to really worry about maybe your session type has some information that a certain user shouldn't be able to see, and you have to make sure to remember that, you know, now you need to add that in because it wasn't there before, but you're using this type here. There's none of that. You're building these types out for the specific purpose that you need them. So all the data is good to see. Yeah, and one other nice benefit is there is a clear separation between our database table and our tables and our UI. Sometimes it can be really like a simple trap to fall into where mentally you really think of your UI models and your database models as one of the same, and you don't put more of a separation on that, but this is a way to help you fight that. So that's great. Big Boss Lily is really happy with that. But of course, with everything, there are drawbacks. There's now more data mapping in the back end. It has to happen somewhere, and you know, maybe that's not a drawback for you, but if your back end is really complex or you're not that good at back end, that could be a drawback. The main one is that these new GraphQL types aren't reusable anywhere else. You're going to have potentially some duplicated code, which could be mitigated with shared services in your backend that end up the same resolvers or different resolvers end up calling, but there will be more code duplication. And then my personal pet peeve is that the types have to be unique. So you end up with really long type names like attendance dashboard cohort or attendance dashboard weekday, which I don't love. And there are alternatives that we haven't discussed. Like, for example, there are a lot of nested filters that could be added, like for the sessions or for getting present student attendance records, for example. But I do find that that has a lot of the same drawbacks, which is you still end up doing a lot of data mapping on the front end. And then the same thing for like custom field resolvers, where, for example, you have the current student attendance type, and you end up fetching it that way, but then you'll still end up having to manipulate that data because it's not going to be exactly what you want. And there are probably other alternatives that I don't know about. Maybe you know about them. So yeah, just to summarize, we went from fetching this data with types that we already had and were intuitive and made sense for other scenarios, but maybe didn't make as much sense for this aggregated attendance dashboard. And we went to a query that asked exactly what we wanted, with all of that data mapping being done on the back end. And yeah, the conclusion is that it's faster, there's better SQL optimization, that's undeniable. There's less data getting sent to the client. It's cleaner, there's a clear separation of concerns. There's clear boundaries between which queries are reusable and which ones are for specific purposes. So you don't have to keep guessing. And there's usually less data mapping overall, and when there is data mapping, it's in one place. And then it's easier because changes are closer to where, like changing your mapping is closer to where the data is getting fetched. So often you can just make the change in your ORM, or you know, it's all closer and it's all more, yeah, it's the same. Cool, that's all. Thank you very much. If there are any questions, we can go over them. Okay.
Thank you. So my question is just like, what's your threshold for when you determine it's time to make a new type for this kind of?
Yeah, Yeah, that is a really difficult one, and I think every case is different. I think when you start to have front-end code that looks like it's doing too much, basically, like it knows too much about what kind of data you are wanting, then it's time to probably make some more custom types. And this is for internal APIs specifically. I don't know about external APIs. Yeah.
Just right here. I'm just curious about like how you balance this philosophy with kind of maybe a desire to have your schema and your types kind of all neatly like planned out ahead of time, which obviously is unrealistic in a lot of circumstances. But like, do you have any tips or strategies for like keeping your schema open and also having your types be able to be kind of formed this way?
Yeah, that's interesting. I actually think this really helps with that in a lot of ways, because I do still think there's a place for reusable types, like there's definitely situations where you can have that, but using this, you do have that separation where you have your types that are just so coupled to a specific component or page that it's undeniable, and then you can be a lot more mindful about how you're building up your reusable types, because you don't need this data in there, so you're just going to chuck it in there. You're thinking more clearly about like what's what. Yeah.
Thanks.
Good question. Okay. I think that's
It's mine
all.
now.
Thanks for the talk. You kind of mentioned transitioning from, I guess, more reusable typings to then less reusable. Would you ever see a world in which you have to then transition back in the future, say things get more complicated?
Yeah, I mean, if I imagine, like, let's say this dashboard, there become so many variations of it that it really does feel like, listen, we can't just keep rewriting these like resolvers over and over again. We need something that will still have these benefits, but will reduce our code. I imagine it'll work similar to like building a new reusable type. You take what you have, and then you start from that as the base, and you go. I don't imagine like breaking up this dashboard to be like, let's go back to using cohorts and sessions and fetching all this data separately. But yeah, that's
Cool,
a good
thank
thought.
you.
Yeah.
Do you have any best practices to share when the data is coming from the multiple subgraphs? So the logic, like where does that go? Like, if like let's say for example, you had the data that is coming from the student and from the absence and the so if there are like two services or the two subgraphs maintaining those data, then where does the logic goes?
Yeah,
in that case?
I don't have personal experience with multiple subgraphs or multiple.
The federation.
Yeah, but I imagine that the client would still just have a single schema that they query from. Yeah.
Right.
And and so I guess there would be some resolver in the back end that would handle the merging of the two subgraphs.
Right. I mean, this is the current problem that we are facing as well.
Yeah.
So we have the one super graph and the giant one.
Yeah.
And then we have so many subgraphs.
Yeah.
And the query, like with each iteration, the different use cases just keeps on growing.
Yeah.
And at some point, you have to make that decision, like, okay, now we need to make a little bit more specific code.
Yeah.
But then there's the data dependency, and in that case, like, it's the problem that we're
Yeah,
trying to solve.
yeah. I guess it would depend on how your backend is written to like combine.
Cool.
Sorry, I can't
No
be more
worries.
helpful there. Yeah.
I just wondered what you used to make the presentation. It's awesome.
Oh my gosh! Shout out to Canva. It's so great. My free trial ran out just before the talk, so that's why there were some watermarks. But I'll sign up for a real account one day. Yeah. Okay, thanks everyone.